I'm Wally from Black Dot Energy, and this is our technical training videos for maintenance and the PIMD component of the WITS for these plant rooms. This first video is very similar to what we've done at David Webster and Bernard Hall as well, and it's really approached to do an initial assessment of the plant room, and we call it the kick the tire test. The kick the tire concept really came from Henning Holm, which does our solar installations, and the principle being, before you go on holiday, you sort of walk around your car, kick the tires, check the flicker lights, and make sure that visually there's nothing wrong with your vehicle or the machine. The same we do here. So when you come into the plant room, you want to do an initial assessment of the plant room and see if everything is functional and working. Alternatively, you might have a complaint that comes in from the students that says that there's no hot water. Where do you start? And that's the function of this video, is to really ensure that there's a high level of understanding so that WITS can comply to their objective of really giving a high service delivery to their students, i.e. hot water at any given point. So with this video, we're going to basically start with the visual components that we've got in place in terms of checking whether everything is functional. So the first point is that here is our main incoming supply line, that you need to make sure that the valves are open. Also, this is the critical point for isolating the plant room. So if anything goes wrong in this plant room, what you need to do is basically close the butterfly valve, then you've shut off all the incoming water to this plant room, and you can do whatever necessary repairs needs to be done. Again, with this plant room, we've done a header system, so we've got a top and bottom header system. So it is also possible to isolate either tank 1 or tank 2 or tank 3, depending on what the requirement is and what you need to isolate. So what we've got is a very good visual display of the system to show us exactly what happens in each storage vessel. The first one being the pressure gauge. So the pressure gauge is just over 3 bar. At this campus, we've built a redundancy backup water system, so 300,000 liters backup water with a pressure pump that ensures that we're getting pressure consistently of just over 3 bar. The 3 bar being important because a lot of these buildings are 4 stories high, and this plant room is below surface level. So we need to at any point have enough pressure in the system to in fact circulate and overcome that head pressure of 5 stories high. And 3 bar enables us to do that. So immediately the first check you can do is, have we got the right pressure in this entire campus? And that you can see on this gauge, and in fact there's a gauge on each of the tanks. At all 3 levels of the tanks, bottom, middle and top, we've got 3 temperature gauges. So in fact on all 3 tanks, at all 3 levels, we can see what the temperature is of the system. So this one, where the cold water from the municipality comes in, or from our pressure pump, that temperature is now at 30 degrees. This entire plant room has been running the whole day with a co-generator. So the middle is at 60 degrees, 60 degrees. So from tank 1, we've basically got the whole system charged up, which is now ready for the evening peak. So there's more than sufficient, in fact, 60,000 liters of hot water available for the evening peak. So the first check, ensure that the valves are open. You can see on the opposite side the pressure from the municipality, so that's the first pressure gauge, and in fact that's on 5 bar currently. Then we've got the pressure behind it with a pressure reducing valve. The butterfly valves are open so that we know that there's incoming cold water. We can see the temperature, we can see the pressure. If that is all consistent and we've got 60 degrees throughout the entire system, the next thing that we need to look at is the ring main functional, and in fact have we got circulation into this plant room. If there's not temperature here and the system is not on temperature, it can be only one of 2 things. Number 1 is that the co-generator has got a problem, and again with the generator we do have temperature gauges to see what's the temperature in and the temperature out. So there we can see, is there loading of energy from the generator. We can also remotely monitor that. Secondly, is the gas burners working? Again, with the gas burners, we have temperature gauges on those, and at the top of the circulation loop with the gas burners, you'll in fact see that it's 65 degrees that we're loading into the system. So for this kick the tire test, when you come into the plant room, it is really in essence to see, is the water supply functional and in fact open? Is there pressure in the system? And what is the temperature on the tanks? In the next videos, we're now going to look in detail at the gas loop. So if we've seen that there's no temperature, what could be the problems and the process of identifying problems with our gas heating? Secondly, what is the problems that could contribute to the generator not producing energy? Thirdly, our solar loop. And then lastly, our ring main and distributing this heat throughout the plant room. Thanks for watching the video. The next videos will be on those remaining technical components. Thank you.